All right, so question number 7 says, consider the following graph. F is defined by that function. It wants us to find the vertical asymptotes and draw them, the horizontal asymptotes and draw them, and where it crosses the x-axis, so the x-intercepts. We don't have to do quite as much as we did back when we went through this in class. Like we actually drew the curve, right, and drew the entire function. It doesn't want us to do those. Just find those 3 things: vertical asymptote, horizontal asymptote, x-intercepts, and graph it. So the first thing I'm going to do is factor the top and the bottom. So if I take an x out of the top, end up with that. If I take a 2 out of the bottom, we can actually factor that further, right? Over 2 times. So even though it doesn't ask for it, the first thing I would do, this is f of x, is I would say what the domain is. Well, we know that x cannot equal 3 or -3, because those will give you a 0 on the bottom of the fraction. Now, those could be vertical asymptotes, or they could be holes in the graph. The way we figure out which one is we take f and we reduce it. So I'm going to take f of x and reduce it. And that's supposed to say reduce there. Those x minus 3's cancel out. That leaves me with x over 2 times x plus 3. Sorry about that. Now, what I look at is if the factor reduced out. So originally we said x could not equal 3 because of that, or -3 because of that. Because the x minus 3 reduced out, that means that at 3, there's going to be a hole in the graph. And we could find where that hole is, but it's not asking us for that. Now, the x plus 3 is still there after I reduce it. That means that at -3, there is a vertical asymptote. Okay, that's going through there. So there's our first thing, is there's a vertical asymptote at x equals -3. Okay, then it wants us to do the horizontal asymptote. Well, to do that, I compared degree, the top and bottom. That's degree 2, and that's degree 2. So there's a 1 in front of the x squared. So my horizontal asymptote is just at y equals 1 over 2, or a half. Now remember, if the degree of the bottom is bigger than the top, then it's y equals 0 always. And if the degree of the top is bigger than the bottom, then there's not a horizontal asymptote. There might be an oblique asymptote, but it's not asking us for that. Okay, the last thing is to find the x-intercepts. Take the reduced form down here and find out what makes it equal to 0. Well, that's when the top would equal 0, right? So at x equals 0, there's an x-intercept. So that'd be the point actually 0, 0. X and y are both 0. Be careful not to include 3. Even though 3 makes the top 0 up here, we said x cannot equal 3. Okay, so if we put that out on our graph, we've got a vertical asymptote at x equals -3 over here. We've got a horizontal asymptote at y equals a half. And I have an x-intercept at 0, 0. And if it asked us to graph the whole thing, we'd maybe plug in a couple points just to check to see what happened everywhere else, but it's not asking us to do that. So let's go ahead and graph those just so you can see how to enter it in on this problem. And then just double check and make sure we got it. So x equals -3, there's a line. So we're going to do a line. Okay, and then there's also one at y equals a half. Be a half right there. And there's a point, we said it crossed at 0, 0. So I think that's everything. Okay, looks good.